Hello, welcome back to Ben Sushi Live Noding. In this episode, I'm going to continue with the explorations of fluid properties using animation nodes. And here I'm gonna show you something. I have this bake fluid simulations, and you can see this is actually I scan my face and then I'm kind of shooting fluid from underneath the face. It's kind of like an open fluid simulations with a outflow at the top, and the gravity is actually I actually switched the gravity to positive. uh, Let me find gravity. Okay, that's the gravity setting. Normally it's this is like a minus 9.81. If you just hover over it and just tap minus, it's gonna kind of invert it. Okay, so the result actually, I got a render here and I'm gonna open it using deja view. This deja, I don't know how to pronounce it. Deja vu view actually can open sequence of image very quickly. I'll get this, just open it. So that's the result. Looking from the top view, you can see the fluids kind of shooting into these obstacles. It's not the most beautiful. Maybe I have to render it differently or use different lighting. But this is kind of interesting. If I'm not wrong, if you're doing the same thing using the flip fluid, you're gonna get a lot smoother result. This result I got, this is at 200 resolution and it's quite high, but we are still getting some, it's not very smooth. With flip fluid, you get a much smoother result. And something interesting here, if you look at it, you can see that my fluid inflow is rotating, and that rotations is actually being driven using animation nodes. It's actually interesting. It's not as obvious when you're first using Blender Fluid, but there is this option called local coordinates. Apart from the velocity, so the velocity is gonna be shooting in Z, but this object also, if I turn on uh, my fluid emitter, which is this guy right here, and if I turn on the axis, so it's gonna be shooting in Z. However, the animation node's gonna drive it and control the orientations. The fluid seems to be so this seems to be like 1 frame delay, but in maybe this is like something that's need to be looked at. But other than that, the animation nodes really affecting the direction. So if you have like, this is like a fluid emitter, it's shooting in Z, emitting in Z in one direction, it's gonna be a bit boring. So I'm using animation nodes and kind of play around with the rotation a little bit, so it's kind of wiggling around, and then so the fluid is gonna be more natural. It's shooting in the, it's gonna cover more area. That's why I can kind of spray on this face a little bit better instead of it just shooting in one spot. So let's try and recreate this very quickly. So file, save as. It's a good idea with fluid actually always save it inside a folder. So I'm gonna call it fluid orientation. Fluid orientation 001 or 00. Okay. And this is gonna be the domain, fluid domain. And by default, this cache fluid is gonna be saved inside the directory that we just created, hopefully. So let's try really quickly, create a icosphere, and I'm gonna switch to wireframe. So with this guy, I'm gonna create axis, and I will actually scale it in the Z, because I know that this icosphere, it's gonna be a fluid inflow and it's gonna shoot in Z. Keep it simple. The Z is where the I think the Z is actually where Suzanne is actually looking at, if I'm not wrong. Okay, Suzanne is actually looking at the negative Y. So with Suzanne, if you want to shoot from the Suzanne directions, you want to do the inflow in minus Y. And this is controlling the strength. So just keep that in mind. Okay. So with our icosphere, I'm just gonna shoot the fluid up. Later on, we can rotate it around, but we need to turn on these local coordinates. You will see very soon. So I'm gonna put it here. So this is the fluid. Let's test our fluid simulations. Just bake it. See, now it's already start baking. At low resolution, this is almost real time. It's not really real time, but you can step through it. Okay, it's shooting. That's it. That's the strength of our fluid at the moment. It's not very strong. It's pretty weak, but it's happening. And then the fluid cache is gonna be inside that folder. Okay, so let's stop the fluid baking. Go back to our icosphere. Let's shoot it in much faster, 3 times faster now. Bake. It's gonna reset, delete the previous cache. Now the fluid's gonna shoot up. It actually hits the top ceiling of the domain. So you can really see the fluids doing its thing. Okay, cool. Now, what happens if I start rotating this guy in local coordinate? So we are expecting it to shoot like that, right? If we run the simulations, stop it, and bake it again, and then scrub again, you see the fluid still shooting up. Why? Because we need to turn on local coordinates. Okay, animated mesh, we don't need it if we are just animating the transformations, unless your object is deforming, and maybe you need to turn on export animated mesh. For now, just turn on local coordinates. By doing that, the fluid can now shoot in the Z directions. I can prove it by keyframing this guy and keyframing like that, and then go to 0, 0, and then keyframe. Now select our domain once again and then bake. Now it's shooting actually in Z, following the orientation changes. And then let's just step through the simulations. And yep, it is working. This is actually what we want. Okay, let's stop our baking. So back to our icosphere. Let's clear everything. Go to 0, 0, 0. What if you have like you kind of want to reposition this guy, right? And you position it somewhere, but you kind of want to have a little bit of rotations automatically. How do you do that? You can do that using animation nodes. I'm gonna show you how. So let's switch to compositing, and with compositing, we have animation nodes. Create new. Let's use object transform output. Get our object, and here turn on the Euler. Now we should be able to control the rotations like this. There is a Euler math that I want to use. I keep pronounce it Euler, but it's actually Euler, if I'm not wrong. It's but I like to just use Euler. It's easier. So this is gonna be the rotations. Let's plug this in. We can use wiggle. So Euler wiggle or Euler wiggle. Plug in the frame into the evolutions. So this will give you 30 degree on every directions. Maybe we don't need it in the Z. We're just gonna kind of rotate it in X and Y. If I play back, you can see, oops, our fluid's still there. Okay, with the fluid, okay, remember you can always change the preview into geometry or something else, or just hide it. For the time being, I'm just gonna hide it. So we have our icosphere starting to wiggle a little bit. It's only like 30 degrees, but you can increase it to 60. So it's gonna be tilting more. It's gonna spray the fluid a little bit more. We can keep it 45, I guess. That seems to be pretty nice. Speed, maybe faster. See, there's a bit of that kind of natural motions. You can rotate it down, for example, like that, 180 degree, and then it's gonna have that kind of extra rotations, which is automatic. So this can be really handy if we are spraying into something. Let's try spraying into cube, maybe create fluid, obstacles, and scale it. Okay, back to our domain, turn on the domain, switch it to wireframe. So now our fluid should be just wire. This should be fine. So we can now shoot the fluid up, kind of like painting these obstacles up here. And let's see what's going on. Fluid bake. So normally I use a small value, 65, and increase it to 150, maybe increase it even to 300 at some point. So now it's kind of spraying our obstacles. Oh, it's hitting the domain outside, but it's gonna hit soon. It's gonna do the painting. Maybe make this even smaller and select the cache, stop the baking, bake it again. At this point, maybe I'm gonna switch fluid back into solid. See, now it's, so it has one it has direction, and on top of that it's wiggling because of animation nodes. I really like this. It's kind of like an extra stuff, you know, that you can add very quickly to add a lot of details with the fluid. And if I have something I can work with, maybe I can get something here. I have a soda. Maybe I have a face that I can work with. So this is the face that I use, and I think it's in my face or someone else's face. Yo, okay. This one was scanned using the iPhone 10. I will use it as fluid obstacles. You have option like partial sleep, free sleep, no sleep. I think it's a good idea to use partial and then just give a bit of amount and then see what's the difference. Impact maybe is useful also. Anyhow, I can delete this, stop the caching of fluid, and use the face instead. It's gonna be more interesting. if the fluid's kind of not what you want, try increasing this or use a different unit. Yeah, let's try this. Bake. I might need a higher resolution, but let's see. So it's spraying into these obstacles. You can see there's a problem right away because this guy is thin. We need to use actually the shell. Stop this. Let's increase the resolutions and then bake it again, but I think I'm just gonna use lower value here, 25 degree. Speed, I'll leave it as it is. So bake once again. So this should be working a little bit better. So I'm using the shell. Spraying into this guy right here. I might need much higher resolution, or even increase the size of the fluid simulation setup. So let's hide this. So you can see it's spraying on the face. In general, with the fluid, you want to smooth it, shade smooth, and then you also add a smoothing 10 times maybe. So this will give you a little bit better result. You can see it's following the face a little bit better, but this is super low res, I guess. I can still go up, stop the simulations, go to 150 right away, and then bake. We need more memory, but if you have multiple CPU, I think I have 6, this should be pretty fast. And I forgot again, by default it's preview. It should also be final. Always forget. So now it should follow the face much better. Alright, maybe I shouldn't. Maybe I'll try to sim this not while recording, but I still want to show you. If I switch the gravity, just tap hover and then tap minus, and then it's gonna be 9.81. Now use 100 and bake. So this is very important. Render display, viewport display. Viewport, this is the final, currently showing the final mesh. You can switch to preview, which is this guy right here, this 45 resolution at 45, final resolution 100. So this guy, when rendered, is still gonna be using the final resolution. But yeah, sometimes you want to see the final mesh displayed in the viewport as well. If you are using Blender 2.8 EV, you can also see the transparency happening. In here, I usually just use matcap and look at the normal. Do it this way. Okay, you can see it's spraying into the face, and maybe the velocity is too strong or something. But you get interesting result very, very quickly. So there you go. That's just a quick quick sharing of this setup. Euler wiggle, but you can, if you want to have it so that the fluid's kind of shooting back and forth, you can use a sine wave. So that's also gonna be pretty easy if you are using this kind of setup. You simply use combine Euler, and with combine Euler use degree and then use math, float math, and then this switch to sine with this value, and then just map the range between -1 and 1, and the output can be any value between maybe 30 degree and 30 degree. Plug the sim here, value goes into the Y maybe, and then plug it to this guy. So this is going to be the offset of the rotations. So what's going to happen is you see this going to move back and forth. See this guy right here? It's going to spray the fluid like that. Okay. All right, that's I guess pretty much it. So the result is looking really weird now, but I guarantee you this can look really nice. So with the fluid kind of leaking up there, remember you can always use the outflow to fix that. So we don't want to have like extra fluid. We can always use the outflow on that surface. There you go, that's fluid and its rotations. Thanks again for tuning in, and I'll see you next time. Thank you. Bye.